Welcome to the Calculus AB video for skill number 152. I can apply the mean value theorem. And as we learned in the last video, another name for the word architrave is epistyle. And the trivia question for today is, what does epistyle mean? What is the Greek interpretation of this word? Alright, so this video is about the mean value theorem, a useful theorem in calculus. And let's first define what this theorem says. It says if we have a function that is continuous on the closed interval a comma b and differentiable, IABLE, at every point on its open interval, a comma b, then there is at least one point C in the open interval AB such that f prime of C equals f of B minus f of A over B minus A. So what exactly does all that mean? Well, we might recognize that this is the equation we use to talk about the slope of a secant line between points A and B, and we know that this is the derivative at C, so this might be the slope of a tangent line. What we're saying is, let me connect these two, hold on. Is that what we have is, if we have some function that is continuous, so here it is continuous from A to B, the slope of the secant line will be parallel to the slope of the tangent line at least at one point within the interval of A to B. So regardless of what the curve looks like, your curve could be doing some crazy thing like that, there will be a tangent line, at least one tangent line somewhere on that curve that has the same slope as the secant line. So in the curvy one that I drew, we actually have three instances that I see. There might be more, but the mean value theorem guarantees the existence of at least one. And it needs to be continuous on the closed interval, so continuous, and then differentiable on the open interval. Let's see how this gets applied in our problem set.
Wow.
Alright, so here we have our problem set. It says find the value C that satisfies the mean value theorem. So I'm going to work through some even problems. Our first equation looks like a root function that's got kind of reflected over in that direction. So we have some function looks roughly like this, and we're interested in the interval from -1 to 4. So the mean value theorem says that the slope from -1 to 4, there is somewhere in that slope between -1 and 4 a point, maybe we'll call it C, where the tangent line has the same slope. I know that's kind of tight on my drawing, but let's work this out. We are trying to find the f prime of C that is equal to f of 4 minus f of -1 over 4 minus -1. So if we want to find f prime of C, we need to find out what is f prime. So that's going to be 1/2, take the derivative, -7c plus 28 times -7. Okay, so there we have our derivative. I brought the 1/2 down in front, and then I subtracted 1, giving me the root in the denominator. The -7 came from applying the chain rule. And this is all equal to the slope of our secant line. So the slope of our secant line, if we plug 4 in, we're going to get 0. If we plug -1 in, we're going to get, let's see, this is minus. Alright, so there's the slope of our secant line. And we're trying to find the c that satisfies it. So we can do some cross multiplication if we want to solve this problem out, or maybe what we're going to do is try to isolate the c. So if I multiply the 5 across, I'll have -35. I'm going to multiply the -√35 down here, and this is all equal to root -7c plus 28. So there we go, and we're trying to simplify this out so we can square both sides. Squaring both sides, and then what we can do is we can subtract 28 and then divide by -7, giving us a c value of 11/4, which is, what is that, 2.75, which does exist within that interval of -1 to 4. So what this means is at the point x equals 2.75, the slope of our tangent line, this red line right here, has the same slope of the secant line from -1 to 4. And that's basically the mean value theorem. You're proving, or you're finding values where the tangent line has the same slope as the secant line. Let's try it out on the next example. Here we have a polynomial, and the derivative of our polynomial, so f prime, is 3x squared minus 8x. So if we want to find a c that satisfies the slope of the secant line, so we need to find out what is the slope of our secant line. So f of 4 minus f of 2 over 4 minus 2. And we can crunch those numbers with a calculator. We get 3 minus -5 over 2, which is 8 over 2, or 4. So we're trying to find the c that satisfies this equation, which we notice is a quadratic. So we can solve it by our means of solving quadratics. And if we tried factoring this, we'd probably hit a brick wall. So let's just jump straight into doing the quadratic formula. So -b plus or minus the square root of b squared minus 4ac all over 2a. And if we simplify this down, we're going to get, alright, so simplified down, there we go. We can actually factor out a 2, and we're going to get 4 plus or minus 2 root 7 all over 3. Now we say plus or minus, but if we go 4 plus 2 root 7 over 3, we're in the interval. However, if we go 4 minus 2 root 7, we're actually outside of the interval. So the only value that we care about is the 4 plus 2 root 7 over 3. So we want to make sure that the values that we find are all within the interval. Okay, for the next problems, it actually says to determine whether or not the mean value theorem can be applied, and then if it does, or if it can be applied, then find the value of c. If it cannot, explain why not. So remember, the mean value theorem says that your function has to be continuous on the closed interval AB and differentiable on the open interval AB. So we take a look at this function, and the only spot that this function is not continuous is at x equals 0, because that would put a 0 in the denominator. So the function is continuous on the whole interval, and then let's take the derivative. So the derivative f prime is going to be the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. And here's another function where the only spot where it is not going to be defined would be when x is 0. So looks like it is continuous and differentiable there, so we can actually evaluate or find the value of c that satisfies this. So we're going to find f of -1 minus f of -5 over -1 minus -5. That's the slope of our secant line. So I like to use a calculator, and you plug this function into your y1, and then you use a table to find these values. So let's go ahead and plug that into a calculator and see what we get. Okay, I got -1.5, and then for f of -5 I got 2.1, and this is all over 4, which is equal to negative 0.9. So we're going to set our derivative equal to negative 0.9 and solve for that variable. So if I go about simplifying the top, I'm going to have negative 4x squared minus, that's plus 2x squared minus 8 over 4x squared is equal to negative 0.9. Negative 4 and 2 becomes negative 2x squared minus 8 is equal to negative 3.6 x squared. Subtract 2, add 2, get 1.6 x squared is equal to 8. X squared is equal to 8 over 1.6. 8 over 1.6, or basically x is equal to root 5 plus and minus. And the positive root 5 is not in our range, so the only viable answer is the negative root 5. Alright, let's look at a couple more problems, and then I think you're free to run the rest of the assignment on your own. So let's take a look at the next one. Okay, same instruction set. Let's take a look at problem 8. Problem 8, what we have here is the negative of the third root of 3x minus 3 squared. And cube roots, oops, that shouldn't erase. Cube roots are always continuous everywhere. Remember, a cube root function looks something like that. So it's continuous everywhere. So it is continuous on our closed interval AB. Now what we want to do is take the derivative. So f prime is going to be, we'll drop the 2/3 down in front, and then we multiply that by 3x minus 3 to the negative 1/3, chain rule 3. And if we simplified our f prime, we're going to get negative 2 over the cube root of 3x minus 3. And here we might have the possibility for it being not differentiable, because we're not allowed to have zeros in denominators. So if there's a value that makes this denominator 0, then it will not be differentiable at that point. So let's see if that ever occurs. We'll say the third root of 3x minus 3 equals 0. If we cube both sides, 3x minus 3 equals 0, 3x equals 3, and x equals 1. So the function is not differentiable at 1, because that would put a 0 in the denominator, and 1 is in our interval. So the function is not differentiable on the open interval 0 to 5. More specifically, it's not differentiable at 1. So because it's not differentiable there, we cannot apply the mean value theorem on this range of numbers. And finally, problem number 10. Very similar thing. We're going to check for continuity, and very quickly I see that at 0 it is discontinuous. So, and 0 is within that range of numbers, so you'd say the function is not continuous. Not continuous on the closed interval negative 1 to 1. More specifically, it's not continuous at 0. And because it's not continuous, we cannot apply the mean value theorem. Alright, I've shown you all the examples that I think should help you do the worksheet. We'll talk more in class, and that concludes the video. Alright, thanks for watching the video. Hopefully you have an understanding now of the mean value theorem. And the answer to the trivia question is epistyle is derived from the Greek word meaning door frame. So you can see what we've got is kind of a column or a pilaster going up, with the top of the entryway being covered with a door frame or the architrave.